Lesson 3.1, Solving Quadratic Equations by Taking Square Roots. What is an imaginary number and how is it useful in solving quadratic equations? Well, an imaginary number is I equals the square root of -1. How is it useful in solving quadratic equations? Well, what if you had something like x squared equals -9? If you took the square root of both sides, you would have x equals plus or minus the square root of -9. And until now, we haven't explained to you how to solve these equations, but today we're going to learn how to. So, investigating ways of solving simple quadratic equations. There are many ways to solve a quadratic equation. Here you will use three methods to solve the quadratic equation x squared equals 16. By graphing, by factoring, and by taking square roots. So solve x squared equals 16 by graphing. First, treat each side of the equation as a function and graph the two functions. In this case, f of x equals x squared. Okay, and let's see, that's going to look something like this right here. And the other half will be messing up. The other half will be something that looks like this right here. And that's f of x, and g of x will equal 16. That'll be right here. This is g of x. On the same coordinate. Identify the coordinates of the points where the two graphs intersect. You'll notice they intersect here at x equals -4 and here at x equals 4. So that's how you solve them by graphing. Solve x squared equals 16 by factoring. This method involves rewriting the equation so that 0 is on one side in order to use the zero product property, which says that the product of two numbers is 0 if and only if at least one of the numbers is 0. So we got x squared equals 16. So let's subtract 16 from both sides. And we have x squared minus 16 equals 0. Factor the difference of the two squares. So how do we get -16? That would be x plus 4 times 4 times -4 equals -16. So x plus 4 times x minus 4 equals 0. Apply the zero product property. So x plus 4 equals 0 and x minus 4 equals 0. Subtract 4 from both sides, and we got x equals -4, and add 4 to both sides, and we have x equals 4. The third method, solve x squared equals 16 by taking square roots. A real number x is the square root of a non-negative number a, provided x squared equals a. A square root is written using the radical symbol. Every positive real number a has both a positive square root written the square root of a and a negative square root written negative a. For instance, the square roots of 9 are plus or minus the square root of 9, read plus or minus the square root of 9, or plus or minus 3. The number 0 has only itself as its square root. Plus or minus the square root of 0 equals 0. And what they're saying here, plus or minus 3, 3 times 3 equals 9, and -3 times -3 equals 9. So we got the equation, write the equation, x squared equals 16. We're going to take the square root of both sides. So x equals plus or minus the square root of 16. Well, the square root of 16 is 4, so that's plus or minus 4. Reflect. Which of the three methods would you use to solve x squared equals 5? Explain, and then use the method to find the solutions. The graphing method would give only an approximate solution. Let's see. The graphing method would give only an approximate solution. Wow. The factoring method can't be used because x squared minus 5 cannot be factored, or isn't a difference of squares. Isn't a difference of squares. However, taking square roots gives x equals plus or minus the square root of 5. Number 2, can the equation x squared equal 9 be solved by any of these three methods? No. None of these methods can be used. Well, why can't you do the graphing method? Well, here's the graphing method. Here you got, here's x squared. All right. And negative 9 is down here somewhere, and they don't even cross. So you can't use that. Attempting to use the factoring method results in the expression x squared plus 9. So graphing cannot be used. Graphing cannot be used. That example right there shows that. Factoring will not work. And that's because it gives you x squared plus 9, which isn't factorable. Attempting to use square roots doesn't make sense. Because square roots of negative numbers aren't defined. Okay. That would be x squared equals negative 9, and take the square root of both sides, and that gives you x equals plus or minus the square root of negative 9. And that's not been defined yet. Finding real solutions of simple quadratic equations. When solving a quadratic equation of the form a times x squared plus c equals 0 by taking square roots, you need to use the following properties of square roots to simplify the solutions. In a later lesson, these properties are stated in a more general form and improved. Product property of square roots. The square root of a product equals the product of the square roots of the factors. In other words, the square root of a times b equals the square root of a times the square root of b, where a is greater than or equal to 0 and b is greater than or equal to 0. Example, the square root of 12 equals the square root of 4 times 3. The square root of 4 times, which equals the square root of 4 times the square root of 3, which equals, well, the square root of 4 is 2, so that would be 2 times the square root of 3. The quotient property of square roots. The square root of a fraction equals the quotient of the square roots of the numerator and the denominator. Symbols, the square root of a divided by b equals the square root of a divided by the square root of b, where a is greater than or equal to 0 and b is greater than 0. The square root of 5/9 equals the square root of 5 divided by the square root of 9, which equals the square root of 5 divided by 3, because 3 is the square root of 9. Using the quotient property of square roots may require an additional step of rationalizing the denominator if the denominator is not a rational number. For instance, the quotient property allows you to write the square root of 2 divided by 7 as the square root of 2 divided by the square root of 7. But the square root of 7 is not a rational number. To rationalize the denominator, multiply the square root of 2 divided by the square root of 7 by the square root of 7 divided by the square root of 7, a form of 1, and gives us this result. Square root of 2 divided by the square root of 7 times the square root of 7 divided by the square root of 7 equals the square root of 14 divided by the square root of 49, which equals the square root of 14 divided by 7, because 7 is the square root of 49. Example 1, solve the quadratic equation by taking square roots. I'll let you go through A, and then when you get back, we'll do B together. So we have negative 5x squared plus 9 equals 0. We're going to subtract 9 from both sides, and we get negative 9. We're going to divide both sides by negative 5. All right, so we get 9/5 over here. And then we're going to take the square root of both sides, and we get the square root of 9/5, okay, which is the square root of 9 over the square root of 5, which is 3 over the square root of 5. And then we're going to simplify the numerator. We are going to multiply the top and the bottom by the square root of 5. So the square root of 5 times the square root of 5 is the square root of 25, which is 5, and then 3 times the square root of 5. All right. Try number 3 here. Solve the quadratic equation by taking square roots. So we're going to add 24 to both sides. So you got x squared equals 24. Then we'll take the square root of both sides, and we get x equals plus or minus the square root of 24. Well, the square root of 24 is 4 times 6. Okay? And the square root of 4 is 2, so we're going to x equals plus or minus 2 times the square root of 6. And there's your final answer. Let's subtract 13 from both sides. We get negative 4x squared equals negative 13. We're going to divide both sides by negative 4, and we get 13/4. We'll take the square root of both sides, and we get x equals plus or minus the square root of 13 over 4. X equals plus or minus square root of 13 over the square root of 4, which is 2. Solving a real-world problem using a simple quadratic equation. Two commonly used quadratic models for falling objects near Earth's surface are the following. Distance fallen in feet at time t in seconds, d of t equals 16t squared. Height in feet at time t in seconds, h of t equals h sub 0 minus 16t squared, where h sub 0 is the object's initial height in feet. For both models, time is measured from the instant that the object begins to fall. A negative value of t would represent a time before the object began falling. So negative values of t are excluded from the domain of these functions. This means that for any equation of the form d of t equals c or h of t equals c, where c is a constant, a negative solution should be rejected. Example 2. If you drop a water balloon, or example A, example 2, write and solve an equation to answer the question. Give the exact answer. And if it's irrational, a decimal approximation to the nearest tenth of a second. All right, A. You go ahead and read through A, and then when you get back, we'll do B together. The rooftop of a 5-story building is 50 feet above the ground. How long does it take the water balloon dropped from the rooftop to pass by a 3rd-story window at 24 feet? Using the model h sub t equals h sub 0 minus 16t, solve the equation h of t equals 24. When you reach the step at which you divide both sides by negative 16, leave 16 in the denominator rather than simplifying the fraction, because you'll get a rational denominator when you later use the quotient property. So here we go. We have 50, the initial height, 50 minus 16t squared equals 24. All right. We'll subtract 50 from both sides, and we'll get negative 16t squared equals negative 26. Divide both sides by negative 16, and we get 26 over 16. Take the square root of both sides, and we get 26 over 16. Well, the square root of 16 is 4, so we're going to get the square root of 26 over 4. Reject the negative value of t. The water balloon passes by the 3rd-story window in the square root of 26 over 4, which is approximately 1.3 seconds. And square root of 26 divided by 4 is 1.3. 5. Discussion. Explain how the model h of t equals h sub 0 minus 16t is built from the model d of t equals 16 times t squared. Think of h of t, a falling object's height h at time t, as the distance that the object has left to fall. Since the total distance to fall is h sub 0, h sub t, or h of t, is the distance left after subtracting the distance already fallen, d of t from h sub 0. We write that out for you. Think h of t, a falling object's height, h at time t, as the distance that the object has left to fall. since the total distance you can't really read that. Since the total distance to fall is h sub 0, h of t is the distance left after subtracting the distance already fallen. D of t from h sub 0, the initial height. Your turn. Write and solve an equation to answer the question. Give the exact answer and, if it's irrational, a decimal approximation to the nearest tenth of a second. How long does it take the water balloon described in part B to hit the ground? Okay, so here we're going to have h of t equals h sub 0 minus 16t squared. And we're going to solve for h of t equals 0. That's the ground. So what do we got here? So we've got 50 minus 16t squared equals 0. Okay, equals 0. So we're going to subtract 50 from both sides. We got negative 16t squared equals negative 50. Divide both sides by negative 16, and we got 50 over 16. Take the square root of both sides, and you got t equals plus or minus the square root of 50 over 16. Well, let's see. That would equal plus or minus the square root of 50. Wouldn't that be 25 times 2 over the square root of 16, which is 4, right? So t equals plus or minus 5 times the square root of 2 over 4. And if you put that in your calculator, that's going to be approximately 1.8 seconds. So you would have to time it where, it'll take 1.8 seconds for it to hit the ground. On the moon, the distance d in feet that an object falls in time t in seconds is modeled by the function d of t equals 8/3 t squared. Suppose an astronaut on the moon drops a tool. How long does it take the tool to fall 4 feet? So it gives you the equation d of t equals 8/3 t. So d of 4 would be 8/3 t squared. So d of t, we're just going to put 4. Okay, we're going to put 4 in for d of t. And let's see here. If we multiply both sides by 3, we get 12 equals 8t squared. Divide both sides by 8. So 12 over 8. Let's see, 4 goes in that 3 times. And that 2. So we got 3 halves equals t squared. And take the square root of both sides. And we got t equals plus or minus the square root of 3 over 2. Let's see, which equals the square root of 3 over the square root of 2 multiplied by the square root of 2 over the square root of 2, and we get the square root of 6 over the square root of 4, so t equals plus or minus the square root of 6 over 2. Put that in your calculator, and that's approximately 1.2 seconds. 1.2 seconds. Now let's define imaginary numbers. You know that the quadratic equation x squared equals 1 has two solutions. The equation x squared equals 0 has one real solution, and that the equation x squared equals negative 1 has no real solutions. By creating a new type of number called imaginary numbers, mathematicians allowed for solutions of equations like x squared equals 1. Imaginary numbers are the square roots of negative numbers. These numbers can be written in a form b times I, where b is a non-zero real number, and I, called the imaginary unit, represents the square root of negative 1. Some examples of imaginary numbers are the following: 2i, negative 5i, negative I divided by 3, or negative 1/3 times I times the square root of 2, I times the square root of 3 divided by 2, or the square root of 3 divided by 2 times I. Given that I equals negative 1, you can conclude that I squared equals negative 1. This means that the square of any imaginary number is a negative real number. When squaring an imaginary number, use the power of a product property of exponents. A times b to the m equals a to the m times b to the m in power. All right. Find the square of the imaginary number. So we have 5i, and we're going to square it. 5i squared equals 5 squared times I squared. Well, 5 squared is 25, and I squared is negative 1, so it equals negative 25. Here, we're going to take negative I times the square root of 2, and we're going to square that. So that's going to give us negative square root of 2 squared times I squared. Well, I squared is negative 1, and this negative square root of 2 squared is just 2. So your answer is negative 2. By definition, I is the square root of negative 1. Does negative I have another square root? Explain. Yes. Yes. Negative I is also a square root of negative 1. Because squaring negative I also gives negative 1. Your turn. Find the square of the imaginary number. Number 9. So we're gonna have negative 2i squared, negative 2i squared, and that's going to equal negative 2 squared and I squared. Well, negative 2 squared is 4 times, and I squared is negative 1, so that equals negative 4. The square root of 3 over 3i. Okay, so we're going to have the square root of 3 over 3i squared, and that's going to equal the square root of 3 over 3 squared times I squared. Well, the square root of 3 squared is 3, and 3 squared is 9 times negative 1, that's going to give you negative 1/3. Cool. Finding imaginary solutions of simple quadratic equations. Using imaginary numbers, you can solve simple quadratic equations that do not have real solutions. Solve the quadratic equation by taking square roots. Allow for imaginary solutions. X squared, well, I'll let you do A, and then when you come back, we'll do B together, okay? So we have 4 squared plus 11 equals 6. So write the equation and then subtract 11 from both sides. And that's going to give us 4x squared equals negative 5. We're going to divide both sides by 4, and that's going to give us negative 5/4. Use the definition of square root, so that's going to be negative 5/4. And it's going to give us the square root of 5 over, and the square root of 4, it's 2, it's 2, and then I. Okay. Number 11, solve the quadratic equation by taking square roots. Allow for imaginary solutions. So we're going to subtract 9 from both sides, and we got 1/4 x squared equals negative 9. Now we're going to multiply both sides by 4 to get rid of the 1/4, and we're going to have x squared equals negative 36. Take the square root of both sides. Maybe do that in a different color. Take the square roots of both sides, and we have x equals plus or minus, what's the square root of 36? See, this is the same as the square root of negative 1 times the square root of 36. The square root of 36 is 6. The square root of negative 1 is I. Okay. So let's subtract 3 from both sides, and we have negative 5x squared equals 7. Divide both sides by negative 5, and you got x squared equals negative 7/5. Take the square root of both sides, and you have x equals plus or minus, and then we've got the square root of negative 7/5. Well, let's multiply the top and the bottom by the square root of 5, and that will give us x equals plus or minus the square root. Let's don't do it like that. 7 times 5 is 35, so you got the square root of 35. 5 times 5 is 25, the square root of 25 is 5, and then the negative 1 is the I. Elaborate. The quadratic equation 4x squared plus 32 equals 0 and 4x squared minus 32 equals 0 differ only by the sign of the constant term. Without actually solving the equations, what can you say about the relationship between their solutions? The first equation has imaginary solutions. Wow. The second has real solutions. But the solutions will only differ by the factor of the imaginary unit I. All right, and you're probably not really understanding that. Let's see if we can. We'll shed a little light on that. Okay, so we have 4x squared plus 32 equals 0. We're going to subtract 32 from both sides. So we got 4x squared equals negative 32. Divide both sides by 4, and we got x squared equals negative 8. Take the square root of both sides, and we got x equals plus or minus, let's see, that would be square root of a is the square root of 4 times 2. So that's going to be 2 times the square root of 2i. And we probably ought to write that as 2i times the square root of 2. All right, now let's do the other one. 4x squared minus 32 equals 0. We'll add 32 to both sides. So you got 4x squared equals 32. Divide both sides by 4, and we got x squared equals 8. So take the square root of both sides, and you got x equals plus or minus 2 times the square root of 2. So the only difference is this one has an I and that one doesn't have an I. Okay, that's what we're talking about. 14. What kind of number is the square of an imaginary number? It is a negative real number. All right. Why do you reject negative values of t when solving equations based on the models for a falling object near the Earth's surface? D of t equals 16t squared for the distance fallen, and h of t equals h sub 0 minus 16t squared for height during a fall. A negative value of t represents time before the fall. A negative value of t represents time before the fall. But both models deal only with time after the instant that the fall begins. All right, essential question check-in. Describe how to find the square root of a negative number. The square roots of a negative number, negative a, are given by the imaginary unit I times the square root of the corresponding positive number a. The square roots of a negative number are given by the imaginary unit I times the square root of the corresponding positive number A. Great job, folks. See you tomorrow in class and have a wonderful